Okay, so today our topic is about forces and motion, and basically our topic is about motion, and it's also for our first class of IG Physics in the final. Okay, so here, as you can see here, we have the three chapters in the total lesson. The first chapter is speed, velocity, and acceleration. The second part is motion graphs, and the last part is free fall. Okay. So here is speed and velocity. So we can find that kinetics and motion are surrounded with us in our daily lives, like a very high speed road. Here are many moving very fast cars traveling on the road. So you can just to describe the car as it has a very fast speed, or they can move in just one. They can move a very far distance in just 1 second, right? Okay. So here we found that in just 1 second, they can move in very further distance. We call this a very high speed. So this leads to our first formula, that is average speed equals to distance moved over time taken, as you can see here. So you can also describe a car with a very high speed, and you can say that, oh, in just 1 second, the car moves 10 meter or 100 meter or 50 meter. Yes, it's a very fast speed. So we know that the distance, unit of distance is meter, right? It's meter. And time taken is second. Yes. So the total unit is meter over second. Okay. So here is an example. If a car moves 90 meter in 3 seconds and its average speed is 30 meter per second, here you can set. You can see here, if the car just traveling for 90 meter in just 3 seconds, the velocity is 30 meter per second, right? Because 90 meter over 3 seconds equals to 30 meter per second. Okay. So here's a little bit difference between speed and velocity. Speed is just a number for describing whether the car is very fast or very slow, like 20, 30. But velocity, here's a direction in it, which means that if you want to describe a car with a moving forward velocity, you can set velocity. If you want to set it is moving backward, you can use maybe negative 20 meter per second to describe it as moving backward. Okay, so here is the difference between speed and back velocity. And here is a very basically unit of basic description of speed and velocity. That is the two words. Okay, here are two words is vector and scalar. Vector means it's an arrow. And in our daily life, we found arrow in maybe some landscapes. Yes, it will lead you to the famous places. Yes, and it's just an arrow. It has a direction, and it also has a distance or magnitude, right? But scalar is just a number, just like if you go onto the scalar or balance, all right, balance, you can just measure easily for the mass. This is a number. We not have, the mass doesn't have a forward mass or backward mass or the mass to the left or mass to the right, right? But velocity has the velocity to the left, velocity to the right. So here's the difference between speed and velocity. Okay. So here are the second part is acceleration. What is about acceleration? As you can see here, acceleration means changing velocity over time taken. So I'll give you an example of the acceleration. Maybe it's very hard for you to understand it right now. As we know that acceleration, just like two cars. One is BMW. Yes, it's BMW. Maybe here are some cars for just racing competition. Like some brands will giving a car a very fast engine, a very advanced engine to make it very fast, right? So here BMW, some of the cars can just equipped with very fast engine, makes very fast. And besides, there are other cars like Toyota, like Toyota. And Toyota, the velocities, and it's very famous for the constant speed, and it's very stable, and it's very safe, right? And you can use it for many years. This is why Toyota very famous. Okay, so you can find there are difference between two cars. The first car maybe is for the racing competition, so it can just increase in speed at a very short time. Maybe for 1 second, it can increase the speed for 20 meters per second. As you can see, some racing in maybe in the movie or in the television, you can find there's a sound of boom boom like this. Can just in 2 seconds, 3 seconds, and it can have a very high speed. But for the car we daily use, like Toyota, it just can remain the constant speed, and it maybe take for a longer time for you to accelerate the velocity. So maybe the Toyota, you have to um, accelerate its speed in 1 second to accelerate to 10 meters per second. Okay, so here are the difference between the two brands. Okay, so here you can find that BMW is accelerating more than the Toyota, right? And now we just use a new unit or use a new parameters to describe the acceleration. That means in just 1 second, the velocity of the car increases. So here you can use acceleration equals to velocity minus the initial velocity. Like the initial velocity when the two cars are stay still, the initial velocity maybe equals to 0. So the final velocity minus the initial velocity equals to the velocity change in the car, right? So here is 20 meters per second minus 10 meters per second. Oh, sorry, over minus 0 meter per second over the maybe for the time taken. Time taken here is 1 second. So for BMW, you can find the acceleration here is 20 meters per second square, right? Means that it can accelerate very fast. Here is 20 meters per second square. And for the car Toyota, also like this kind using the formula U minus V, final velocity minus the initial velocity over the time taken. It is 10 meters per second, and minus the initial speed is stay still at this time, so it's 0 meters per second, and the time taken is 1 second. So here the acceleration is 10 meters per second square. Okay. So now you find the difference between the two cars, and you can describe that, oh, BMW is a better car maybe than Toyota because it can accelerate very quickly. Okay, so here's also a timetable with velocity. You can see here at the first 0 seconds, when the starts accelerating, the velocity of the car equals to 0, means that stay still or don't have a motion. But for 1 second, the velocity increases to 3 meters per second. For 2 seconds, the velocity increases to 6 meters per second. So you can also find in this table, the acceleration just equals to the changing velocity over changing time, right? So in every per second, the velocity just shifting from 3 to 6 to from 6 to 9, from 9 to 12. They're also equals to 3 meters per second. And the time taken is 1 second. So the acceleration here is 3 meters per second square, right? Okay, so now let's just have a comparison with acceleration and velocity. For velocity, you can find easily here is just to describe whether the car is very fast or slow. But acceleration is to just examine whether the car can accelerate its velocity very fast or very slow, whether it's a racing car or it's a normal car.